Hello, this is Dr. Young. I'm going to go over your Chapter 8, Week 8, Chapter 8 lecture. So this week we're going to talk about sustainability, which is obviously, it's the hardest part of Lean, is sustaining it. It often fails. And a lot of companies use it more like a project-based, and once they reach the goals that they set for themselves, they'll just kind of fall back into the older methods. And we talked about Taylor's principles, but many organizations do function under those principles, and they don't understand Lean. They've reduced it to 3 broad efforts: reducing cost and generating savings in the form of projects, use of meetings and maintenance practices without purpose, and progress reviews that measure savings from cost reduction activities and best practices. So sustaining it is the hardest part. Very hard. And it has to be supported by a regular stream of better products. Seeing products as a stream of value is important. It's hard to maintain it. And there can be companies led by lean thinkers, but if they're replaced by other types of managers, the old thinking usually reinstates itself. But it can be sustainable, but these 2 conditions really need to be met. And so that those products that are constantly being innovated have to be supported by technology that's innovative as well. In that case, and this kind of goes back to your manufacturing examples and your machinery, because during that whole manufacturing process that we've been talking about pretty much the whole term, the machines need to be constantly updated, and sometimes there'll be some innovation in that area, and then those are updated as well. So that's kind of a tie into this evolution of technology. Because a lot of times a new product will come out, but a new machine will come out that will make that product better. Therefore, you're actually also updating the hardware that you use as well. So usually those are kind of hand in hand. Lean thinking creates the basis for better products, and it creates products that are innovative, but also features that are as well, because when you're thinking about what you can do better, you're not just thinking about, well, what can I do better to make how can I make this product better, but how can I make the process to make this product better or more efficient? But what about the product in itself? How can we make the product better, more innovative? And usually that has to do with features. And also, a wider range of products without cannibalization. Very distinct products. You're offering products that are definitely distinct from one another and will not cause any overlap. You know, Toyota manufactures different cars that are geared toward people in different stages of life or different lifestyles overall, for example. Consider takt time of product evolution. So there has to be a disciplined rhythm of product evolutions. You have to find a way to include more value without straying too far. And some examples would be iPhone releases and Toyota Corolla. And that's an example on page 202. I'd read that. That's a good example. You know, the Toyota Corolla has been around for a long time. It's it's the most popular car, I believe. A lot of times, I don't know if it is every year, but it doesn't get too fancy. It doesn't get too many bells and whistles on it. It does update its technology, but it's very careful how it does it. It doesn't go overboard. It still targets the same market and customer base there. iPhone's the same way. It adds something to the phone, but it usually doesn't do anything overly. It doesn't change it to where you don't know what it is and don't recognize it and don't have that. You know, if I bought one 4 years ago, 5 years ago, and I bought the new one, I could still use it. I would still know instinctively how to use it, but it would have more features. It's very careful about how it innovates. So, how is value formed? Products are the outcome of dialogue between chief engineer and the department head early in the development process. Page 209 gives you an example of that. I would read that. Yeah. In that case, you need to ask questions like, who the customer is, what do they want, what do they use, what do the engineers want to do, and what does the environment allow. So these are all questions that you need to be asking, because you have to find out as far as what is the customer value and what's possible from an engineering standpoint, and how do those meet. But you got to know who your customer is. All right. So flow Kaizen burn. This is a learning exercise, and it helps. It forms the foundation for continuous improvement. It's practiced every day and becomes the way you work, and some people see it as a one-off process, but it's not. It's constant. So what you want to do there is read the control box. Look at the control box examples in your text, and see. You can see it has a layout, and it talks about the flow. And you see everything laid out there, and then you can see you list the opportunities and then the corrective actions. So if you go to your chapter, so when you do a flow Kaizen, it's easy to see the opportunities for lowering the times and responding to customers. Now, in this example, a flow team was working on a control box cell, and they reduced staffing from 10 to 5 operators. And they even might have been able to get to 4 in that first week. So they reduced operators, manpower, they reduced space, they reduced inventory, and travel distance. So when you cut all that, you can cut lead times also from 6 to 1 or 2 days. 6 weeks to 1 or 2 days. That's amazing. So read through that and just make sure you can see what, understand what, like for example, there's that main on page 137 as that manufacturing sequence control box. So it kind of gives you an idea of the steps you need to take. And then you can consider how long it takes you to do each step. And then how many operators do you really need to do that? And so it goes through that whole process. So you start with the highest volume product. You lay out the step-by-step sequence in which the product is made, which is that control box is kind of like what that was. Confirm tack time. Then you conduct the time observations of it and how long each task takes. Then you create loading charts that help demonstrate the wasted time. And then one-piece flow chart is the movement of equipment and creation of a new cell. And that really is kind of illustrated in that chapter. You can see the one-piece flow chart on page 141 and the layout there. And your raw material, your step 1, 2, 3, 4, and it goes all the way around until you're finished good. So it really gives you a visual of how it should be laid out. If you look on the above that, on the top, you can also see that standard work sheet, which basically tells you what each operator is doing. Excuse me. The loading chart is on page 140, which we were talking about here. That helps you demonstrate some of the waste. As well. And it kind of helps you understand how much time the operators are working. Which number 5 is only working 17 seconds, where the other 4 are working 70 seconds. So that's waste. Because that 5th operator isn't working, so there might be a way to get that to remove the 5th operator at some point. Obviously not at this stage, but continuously working on that. You might be able to do another Kaizen to eliminate that 17 seconds for the 5th operator. So you see how that works? So dealing with pushback of so many changes so fast. Can you imagine going through this and then everyone being like, oh, what did we just do? Wow, this is so, first of all, a new way of thinking of things, a new way of working. Your manager's not even working the same way. That manager is more of a consultant role. You are having to come up with ways to cut time and waste, and in this case, space, time, labor, everything. So you're going to deal with pushback. Some people aren't going to be on board. You're really going to some people are going to get frustrated. So definitely this is a big change for everyone. And it can be nerve-wracking. I mean, it really can. So this is something you want to consider. So, water spider route. What is that? It's the material handler. It means, the Japanese use another term. Mizusumashi. I believe that's how you say it. It means water spider. In Lean, it's different from the traditional idea of material handler. It's the raw material. Think of the raw materials in the process. And this is on page 147. The water spider is responsible for supplying the right parts at the right time in the right quantity so that the line never runs out. However, we have to worry about not carrying too much inventory. So that's always going to be important. It requires a highly skilled person who can think ahead and take initiative. So this is definitely a different role than someone in a traditional structure, because a lot of times that person's thought of as a lower skill worker, but in this case, with the lean transformation, they need to be a little bit more skilled than that. So, you remember the cell that I just talked about was back in the flow chart, one-piece flow, which was on page 141 of your burn text. Well, it's the same thing on page 147, your water spider route, except the parts rack, where the parts are going to be located. So there's a little bit of a different, there's the addition of this person in here in the equation now, instead of just the regular flow that we saw in the other chart. So you have to draw the cell and determine what parts have to be supplied. Where do the parts go? And you have to store those parts. So you'd have to have this water spider visit every 20 minutes. In the text it talks about visiting 20 minutes. So this person's going to supply the parts to create the flow. So you have to consider where that person comes in to the flow here. Where do they go, and what do they add? How much time do they add to the process? How often do they need to come around to supply the parts? So that's what that's about. Making adjustments to remove the fifth operator. We talked about that. So that's going to be another, they're going to come back to that. They're going to try to remove that operator that was there for 17 minutes only, versus the rest of them, which were there for 70. So that fifth operator, there's a bunch of wasted time there. So they're going to need to do that. And during the process, the lean leader's role changed into more collaborative presence than authoritarian, which we've talked about that. It's definitely a big change there. More consultant, less directive. So that's really all. I would just make sure to read that chapter and make sure you understand how that process worked. That flow team, there were at the end of that chapter, they did create some corrective action. They did reduce cycle time. They did create a pull system, but they're going to continue to do this process over and over again. And it's not a one-time thing. They're going to do this all the time. Now, no doubt that first, those first couple of times you're going to see the biggest difference, but that doesn't mean that the smaller incremental differences are not important. That should continue to go on, because they're important as well. I mean, they should always pretty much continuously go on. And that's the difference between an organization that it sticks with, that sticks to lean and actually changes, and those that don't. One that, an organization that doesn't would probably stop at that point and then just kind of go back to the way they always did things. So, that's all for this week. If you have any questions or concerns, please let me know. Thank you and have a great week.